So we're going to be starting a unit here that goes over congruency in greater detail. So one of the things that we know is that if you take any kind of shape and move it around, so if I were to move this guy around, then I would be translating it, and that would make it still congruent. If I were to rotate this guy into another position, that would also keep it congruent. And if I were to reflect this guy, that would maintain congruency as well. So with that all in mind, let's go forward and start exploring how we can use our logic and a little bit of math to solve for a whole bunch of missing angles, missing side lengths, etc. And just using logic without anything else, we can figure it all out. So one of the things to remember is that on a line, and you can see this right here, on a line is going to give you 180 degrees. So you can sort of see how this guy's winding up over here at 180, starting at 0. This line right here then is going to be a 180 degree angle. But it is divided by this guy right here, and we can use some logic to figure out exactly what these angles are, even though we're not given any of them. So one thing that's key here is that one of the givens is that lines M and N are parallel, and that lines P and Q are also parallel. So with that in mind, there are some things that we can use, some tools at our disposal to start figuring out what the missing angles are. All right, so one of the things that's very useful, going back to that 180 degrees, is that we know if a line is 180 degrees, and we know 72 degrees of that 180 is right there, so I subtract 72. I should figure out what is left. So I can't take 0 minus 2. I'm going to have to borrow, turn this into a 10. 10 minus 2 is 8, and 17 minus 7 is going to be 10. So I've got 108 degrees. And then one of the other things that we know is that this is on a line, which means that this guy has got to be 180 degrees. And so what we can see here happening is what we call vertical angles. Whenever we see two angles that are across from each other at some sort of intersection of two lines like this, you know that they're going to be the same. So that also means that this guy's got to be 72 degrees as well. Well, one of the things that's useful about knowing these guys are parallel is that if you can form this Z shape right here, then what you can do is you can know that this guy's also got to be 72 degrees because we have something called alternate interior angles. All right, so up here we had vertical angles, and down here we're seeing alternate interior angles. So that means that these two angles have to be congruent as well. Well, let's think about this for a second. If this were like a piece of wood and you had some kind of projectile, like a bullet going straight through it, you would expect that the projectile really wouldn't be affected very much going in by the actual piece of wood. It's going to go in and come out at the exact same angle, right? So if this guy's coming in at 72 degrees, it's also going to be exiting at 72 degrees. So knowing that these guys are parallel, like two sides rather, of a piece of wood, all right, you can kind of see logically why that guy and that guy would also have to be 72 degrees. All right, so if this is also a line, we got 108 degrees. We call these guys supplementary angles. And those are guys that add up to 180 degrees, all right? And then we got our vertical. I got our vertical right here, that's 108, all right? And then let's do that little neat trick one more time, all right? I can make this Z right here, and I've got alternate interior angles with Q crossing through M and N. Cool. So if this guy's got to be 72, we can start solving this guy out. 72 is vertical to that. 108 is its supplementary angle. 108 is now vertical to that. And cool, cute trick one more time. Bam, bam, bam. Another alternate interior angle, 72 degrees. Vertical angle is going to be 72. The supplement's 108 degrees. Its vertical angle is 108 degrees. And as promised, we have solved this puzzle pretty quickly even though I was only given one angle in it.